Okay, so next up, this last example reads 2 sine of 2x equals 1, and we're looking to solve for all angles in the interval from 0 to 360 degrees. Right away, I noticed that sine of 2x is a double angle for sine function, and I'm going to want to manipulate that using the double angle identity. So at this point, sine of 2x can be manipulated into 2 sine x cosine x. So at first, the 2 in front of the original equation is right here, and I'm going to group it, equals 1. Sine of 2x is going to become 2, and then sine x cosine x here. Right? At this point, I now have a function where, one side of my equation in terms of sine and cosine, and that may be a little uncomfortable for some of us. But what happens now is we're likely to want to distribute the 2 here. Now, when you do this, notice that the blue expression, 2 sine x cosine x, is one term. So you're really multiplying the black 2 out front one time to the 2 in the blue expression here, which gives us 4 sine x cosine x equals 1, and then we move on to solving. So at this point, I have I want to isolate my function. So I'm going to divide all sides by 4. That'll leave me with sine x cosine x equals a fourth, which is positive. And at this point, it's what do? We have a sine x and a cosine x. And how do we isolate this and factor? It doesn't, nothing seems to look like it'll work. We can't divide by sine, we can't divide by cosine. I can't convert sine into cosine at this point. I can't convert cosine into sine at this point. I can't even convert this into a tangent function at this point, the way it's written. So we're kind of stuck. We can't use the zero product property at the moment. So we kind of run into a dead end at this point, right? So here, what we're going to do is, we're going to put this on pause, realizing the double angle identity in this particular problem isn't working for us, but we can still solve this. We've worked on it in chapter 8, and we worked on it some in chapter 9. That's where, if you remember correctly, now we're referring to this as the double angle right here, sine 2x. But we also referenced this too as the angular frequency when we started studying the graphs of these functions, and then started solving equations where the angular frequency wasn't 1, and then we had to manipulate the interval here. So this is a scenario that kind of forces us back to that practice where we're going to have to go through that process, right? So it's almost like starting the problem again. So what I'm going to do is get rid of this information here, and then first thing we do is kind of manipulate our interval. So my interval right here needs to be modified into, so remember, we multiplied the entire interval by our angular frequency of 2 here. So now we're looking for all angles in the interval from 0 degrees less than or equal to 2x less than 720 degrees right now. Okay, so now we're dealing with this situation. 2 sine of 2x equals 1. We're going to isolate sine of 2x right now. So I'm going to divide both sides by 2. And what I'm left with is sine of 2x equals positive half. At this point, what we need to do is find our critical angles at this point before we go and take the inverse sine of anything. To find our critical angles, we're going to isolate that 2x first. So I guess we're going to take the inverse sine, or if you recognize that 1/2 is a special ratio, when we do that, we're going to end up with a 30-degree angle, right? So if you're referencing the unit circle right now, this ratio is positive, which means we have an angle in the first quadrant. We're also going to have an angle in the second quadrant here. Both of these angles are going to have the same reference angle. And at this point, that reference angle is going to be 30 degrees, right? So this is a 30-degree reference angle. This is a 30-degree reference angle. So in terms of my equation now, once I take that inverse sine of both sides, I'm going to have 2x, which we don't want to touch, is equivalent to 30 degrees. Right? So 30 degrees is my first base reference angle. And then, I'm going to find that second quadrant angle from here. So that's going to be 180 minus 30 degrees, giving me 150 degrees as my second quadrant angle that I need to work with. Moving further down the road, so what we're going to have is 2x equals 30 degrees. We also have 150 degrees here. Right? And if you remember correctly, when we're solving these equations where the angular frequency is something larger than 1 or anything other than 1, we have to keep adding intervals of 1 full rotation to both of these base critical angles until we are outside of this region right here, 720 degrees. So I'm going to start with 30 degrees and I'm going to add 360 degrees to that. So that's going to give me 390 degrees next. So before I do that, I'm going to kind of, we'll just add it. So that's 390 degrees. I'm going to add another 360 degrees to 390 degrees. And that's going to push me outside of the interval of 720 degrees. Do the same thing for 150 degrees, right? So I'm going to add 360 degrees to 150 degrees. So when I add that 360 degrees to that 150 degree second quadrant angle, I end up with 510 degrees. And if I add another interval 360 to 510, it puts me outside of that 720 degree interval. So at the moment, I have 4 angle solutions: 30 degrees, 150 degrees, 390 degrees, and 510. Once we're at this point, now we can go through and isolate x, where we divide all angles by that coefficient of x. So in this case, it's 2. Doing so leaves us with our problem set of 15 degrees, 75 degrees, 390 degrees. What is that? Gives us 195 degrees, and 510 divided by 2 is 255 degrees here. So these are our 4 angles for this solution. Again, we attempted to use the double angle identity for sine. We ran into a roadblock, and then we had to resort back to solving a trig equation where the angular frequency is any value larger than 1. Just remember that you have to increase your interval here, modify it at first. Then we're going to add intervals of 360 degrees once I find these 2 initial base angles, 30 degrees and 150 in the 2 quadrants 1 and 2 here. I continue to add 360 degrees to each one of these until I am outside of my interval of 720. Once I'm there, then I isolate my variable x, divide everything by 2, and then I have my 4 angles here.